Hello guys, I am Sagar from Svce College of Engineering. Today I am going to discuss about the kernel modules in the operating system. Let's see the introduction. Kernel modules are the piece of code that can be loaded and unloaded from the kernel on demand. They are the powerful tool for extending the functionality of the kernel. In this presentation we are going to cover the basics of the kernel modules, from the loading and unloading to creating our own modules. Now let us see what are the kernel modules. Kernel modules is a piece of code that can be loaded and unloaded from the kernel on demand. They allow you to add or remove the functionality from the kernel without having the recompiled it. Modules can be typically used to add the support for new hardware, file systems and network problems. In these modules, they are support for typically used to add the support for new hardware like file systems and network protocols. Now let us see the loading and unloading modules. Loading and unloading modules. Loading and unloading modules is the simplest process. You can use the insmod command to load the module, and you can use the immod command to unload the module. It is important to make sure that only you load modules that are compatible with your kernel versions. Now let us see the module dependencies. Module can have the dependencies on the other modules. If a module dependencies on other module, the module must be loaded first. You can use the mod probe command to automatically load any dependencies. Module parameters. Modules can have the parameters that can be set when the module is loaded. You can use the mod probe command to set their parameters. Parameters can be used to customize the behavior of the modules. These parameters are used to customize the behavior of the module. Compiling and installation a module. Compiling and installation a module is a simple process. You can use the make command to compile your module. Once your module is compiled, you can use the insmod command to load it into the kernel. Now let us see how to debug a module. Debugging a module. Debugging a module can be a challenging process. You can use the printk function to print the messages to the kernel log. These messages can help in to diagnose the problems with the module. You can also use a debugger like GDB to step through your code. You can also use the GDB to step through your code. Best practices. When working with the kernel modules, it is important to follow the best practices. Always test your modules on a development system before deploying them into the production system. Make sure that your modules are compatible with your kernel versions, and always make sure that your modules are secure and don't introduce any vulnerabilities into your systems. Now let us see the module management. On Linux systems, the mod probe and ismod commands are used to load the modules, while rmmod is used to remove them. Module dependencies are managed, ensuring that required modules are loaded when a module is loaded. Now let us see the module directory. On Linux, kernel modules are typically stored in the lib module directory. Each kernel version has its corresponding subdirectories, and the modules for the kernel versions are stored here. Each module has the corresponding subdirectories which the modules of the kernel versions are stored. Module configuration. Module configuration for modules can be found in the modprobe.d files, which specially option and settings for the specific modules. These module configurations and configuration of the modules was stored in the modprobe.d files, which was specially options and settings for the specific modules. Now let us see the module and auto loading. The system can automatically load the modules when the hardware is detected. This is often managed by the tools like udiv or Linux. By using the udiv on Linux tools, we can automatically load the modules. Now let us see the module information. You can obtain the information about loaded modules using the commands like ismod to list the loaded modules and mod info to display the details about the specific modules. By using the ismod command and using the mod info command, we can load and display the comments or details in the comments as a specific module. Module security. Kernel modules can be potentially pose a security risk if not properly managed. Secure bot and kernel modules signing are mechanisms used for the mitigate for these risks by ensuring only the trusted modules can be loaded. By only trusted modules can be loaded by ensuring that we can only load the trusted modules. If any untrusted modules has been occurred, it was not supported by the security module. Now let us see the module security. Kernel modules can potentially pose the security risk if not properly managed. Secure bot and kernel modules signing their mechanisms used to mitigate their risks by ensuring that only trusted modules can be loaded. Kernel module development. Developers can create their kernel modules to extend their kernel functionality or provide support for new hardware. They need the knowledge of the kernel's internal APIs and development tools like kernel build systems. Now let us see the compiling the kernel modules. If you are developing a custom kernel module, you will typically need to compile it against the kernel headers for your specific kernel versions. Kernel modules are usually written in the C language and the build process can be managed using the kernel's build systems. It was normally built or written in the C language. Kernel modules are usually written in the C language. Now let us see the kernel utilities. Tools like modprobe, ismod, rmmod and ismod, especially module management. The depmod command generates the module dependency information. Ismod is also shows the reference count, which indicates how many instances of a module are currently in use. Module. Now let us see the block listing. Sometimes you may want to prevent a module from the loading automatically. You can blocklist the modules by adding their names to the configure the file. Sometimes you want to block some modules. So at that time, by using their names, we can add to that modules to the block list. Kernel module signing. Now let us see the kernel module signing. On secure systems, kernel modules can be signed to ensure that only trusted modules can be loaded into the kernel. This is the security feature to prevent the unauthorized code and execution. Now let us see the troubleshooting. If a module is causing an issue or conflict, you can often resolve the problem by unloading it, changing the configuration or uploading it to the newer version. If the module is facing any problems, you can change or resolve the problem by unloading it, changing its configuration or uploading it to the newer version. Kernel modules are the fundamental part of the Linux kernel design, enabling the kernel to be highly adaptable and extendable without the need for a full kernel rebuild. They are critical for the hardware support, file systems and various other system facilities. Now let us see the conclusion part of the kernel modules. Kernel modules are a powerful tool for extending the functionality of the kernel. They allow you to add or remove the functionality from the kernel without any recompile it. By following the best practices and uses the tools available to you, you can create a robust and secure kernel modules. That's it for today's session. See you guys in the next